Now we want to look at, and I am probably going to be pronouncing this wrong, DeMoivre's theorem, maybe? I took French, but it's been a long time. This is a theorem that allows us to raise a complex number to a power. Okay, so you see it here. This is all you got to know. If you're raising a complex number, notice it's in polar form. So it's got to be in polar form to use this. You do, if you're raising this to the nth power, you raise r to the nth power, and then you do the CIS. Remember that shorthand for the cosine of theta plus I times the sine of theta, and then n times the angle. Okay, basically watch and see how it's done. It's not as bad as it looks. Okay, all right, so let's see how we do this if the number's already in polar form. All right, so here we have 5 CIS 137 degrees raised to the third power. What this means what's inside here, and I'm going to write it using longhand. 5 cosine 137 degrees plus I times the sine of 137 degrees. It means all of that times itself 3 times, right? That's what raising something to the third power means. We could do it. We could do it longhand. We could work it out. It would not be real fun. What the theorem allows us to do is to say, well, let's just take that r, that 5, and let's raise it to the third power. And then we're going to do the cosine I sine thing, and we're going to multiply the 137 times the 3. Notice the exponent ends up with 5 to the third power and then 3 times the angle. That's where this 3 ends up. We raise the r to that power, we multiply the angle times that number. Okay, so now we're just going to do a little bit of work here. We're going to get 125 CIS, and 3 times 137 is 411 degrees. Well, the problem with that is it's more than 360, right? This is more than one time around. So how much around is it? Well, we go around here, and if we do 411 minus 360, our reference angle is 51 degrees. So we really want to write this as 125 CIS 51 degrees, because that would be the type of angle we want. We don't want to go more than 360 when we give our answer. So that wasn't bad at all, right? If we were to write all this out, multiply it all out, do all the algebra, we'd get here. The theorem makes it a whole lot easier. If the number is in rectangular form, if the complex number is in rectangular form, it's a little more complicated to deal with, okay? It's still not terrible, but it's a little bit harder. Because we have to get it to polar form to use the theorem, and then we've got to change it back to rectangular form. So I have 1 plus 8/10 I raised to the 6th power. This means 1 plus 8/10 I times 1 plus 8/10 I plus 1 plus 8/10 I 6 times. We don't want to do all that. So even with the little bit of work this is going to take, it's going to be easier than all that multiplication. So the first thing we're going to do is we're going to graph it. This is going to be in the first quadrant, and my x-coordinate is 1, and my y-coordinate is 0.8, right? Well, I got to have that r. I got to have my hypotenuse. So I'm going to use Pythagorean theorem. And I get, and I'm going to round, and I'm probably rounding a little early here. The answer I got is a little bit off from the answer in the book, but it was because of rounding. And as long as you've rounded correctly, it's still going to be okay. R is about 1.3, okay? So I've got that part. The next thing I need is theta. I need that angle. And I want to use the tangent ratio, because the tangent ratio uses 2 that they've already given me. I don't want to use this 1.3 because it's something I rounded. I'm going to use the opposite and the adjacent. So I'm going to say the tangent of theta is 0.8 over 1, which is just 0.8. I'm going to do my inverse tangent function, and I get that my angle is about 38.7 degrees. Okay, so in polar form, this complex number is 1.3 CIS 38.7 degrees, and I'm raising it to the 6th power. Now I can use my theorem. I'm going to say 1.3 to the 6th times CIS 6 times 38.7 degrees. Remember where your exponent shows up. So I use my calculator, and 1.3 raised to the 6th power is about 4.8. I'm rounding. And then 6 times 38.7 degrees is 232.2 degrees. That is less than 360, so I don't have to do anything to fix it. Now, I'm good. I've used the theorem. I'm all good, except the instructions say to leave it in rectangular form. So now I need to take this and I need to change it back to rectangular form. Well, remember what that means is 4.8 times the cosine of 232.2 degrees plus I times the sine of 232.2 degrees. Okay, I'm going to do my algebra, and I'm going to do 4.8 times the cosine of 232.2 degrees, and with rounding I get about negative 2.9, and then I'm going to do 4.8 times the sine of 232 degrees. I'm going to round it, and I get minus 3.8i. Why would both of these be negative? Well, we are in both of these are negative because when we multiplied by 6, we're now finding the sine and cosine of 232, which is in the 3rd quadrant, and sine and cosine are both negative in the 3rd quadrant. Okay, now I skipped the step right here where I wrote out the cosine and I wrote out the sine and then I multiplied. If you have trouble getting this, let me know, and we will do some practice with it.